Welcome to the Crucible of Complexity, where we explore embedding physics in reality. We will cover the epistemology, engineering, and commercialization of deep technology, examining how to bridge the gap between theoretical models and practical applications. The noise filter shows why physics and reality collide. Physics uses aggressive reductionism to isolate predictive power from a messy, real-world environment. Engineering uses pragmatic integration, forcing idealized functions onto imperfect materials. Deep tech requires embedding abstract predictive power into chaotic reality. The epistemological divide matrix highlights the structural cause of deep tech failure. Fundamental physics seeks absolute truth with reductionism, while applied engineering focuses on functional utility and synthesis. The gap between idealized physics and practical engineering is where deep tech often fails. The PhD is nothing paradigm details the Marvin Hewitt paradox. Academic incentives favor hyperspecialization, resulting in a funnel where up to 80% of STEM PhDs leave the sector. This leads to prototypes with profound theoretical novelty, but zero commercial consequence. However, the doctorate has unassailable value. The true asset is the psychological endurance needed to rigorously de-risk complex physical systems. PhD founders demonstrate empirical strength in IP generation, de-risking, and analytical interrogation, making them targets for elite VC firms. We are reinventing the credential with the Venture Science Doctorate, or VSD. This transition moves from descriptive research to an outcome-first, venture methodology driven by industry analysis. The VSD is designed to create founder-type scientists to solve global bottlenecks. Mapping the chasm reveals the technological valley of death. Theoretical concepts require extensive, capital-intensive engineering outside the laboratory. Traditional funding models, like public grants and late-stage VC, fail to provide the necessary capital spike for TRL levels 4 through 7. Deep tech scaling differs fundamentally from software scaling. Software benefits from pre-built networks and rapid iteration. Deep tech is constrained by physical supply chains, thermodynamics, astronomical capex, and decades of R&D misaligned with short-term VC liquidity cycles. To cross the valley of death, a physics-based startup must ruthlessly optimize across the MET's constraint architecture: matter, energy, time, and space. Optimization must be simultaneous across all 4 vectors to achieve commercial viability. Deep tech requires systems thinking because it operates as a complex system, unlike isolated physics variables. A minor theoretical alteration, like increasing laser power, creates a massive ripple effect across thermodynamics, materials, and operations across the entire architecture. The boundary spanner role is critical for translation. These individuals convert the syntactic language of physics into the semantic language of engineering and the financial lexicon of VC. Without them, isolated teams optimize components at the expense of system functionality. The deep tech playbook is the triple helix model, integrating academia, the public sector, and the private sector. This collaboration provides basic science, risk-tolerant funding, and commercial scale-up capital, as seen in highly integrated geographical hubs. The deep tech innovation engine synthesizes all these elements. A traditional PhD, paired with systems thinking, the METS framework, and the triple helix model, becomes an unstoppable engine of value creation. Technological supremacy requires profound, interdisciplinary synthesis. This video explores how fundamental science is the preamble to world-altering innovation, focusing on the epistemological divide between theory and practical application. We see the illusion of the finish line. While physics provides essential mathematical scaffolding, value creation requires exposing these pristine equations to the uncompromising, multivariable reality of the real world. This map illustrates the deep tech valley of death. Isolated theories can die in the chasm, which is the epistemological divide. Value creation requires bridging the gap between theoretical novelty and practical value. To cross the divide, we need a translation playbook involving 3 pillars: masterful systems engineering, boundary spanning, and patient capital supported by the triple helix. One example of bridging this gap is taming the violence of plasma in EUV lithography. This process uses a high-powered laser to create plasma, generating extremely specific 13.5 nanometers EUV light. The challenge is engineering around the laws of matter. EUV light is rapidly absorbed. This requires a flawless vacuum and specialized ZIS multilayer mirrors with atomic-level precision. ASML is the ultimate ecosystem integrator, coordinating a massive machine, a global supply chain, a talent pipeline, and patient capital over decades to achieve viability. Moving to the absolute epistemological frontier, we compare classical reality, which uses binary bits, to quantum reality, which uses qubits leveraging superposition and entanglement, promising vast computational power. However, Hilbert space is fragile. The bottlenecks include decoherence, which instantly collapses quantum states, demanding hardware like dilution refrigerators, and the algorithmic constraint of the barren plateau problem. A shift in strategy is needed toward robust, error-tolerant systems engineering. AI, as the quantum control plane, is critical, exemplified by NVIDIA Ising, which actively calibrates qubits to tame quantum noise. Scaling friction, or tribology, is another deep tech challenge. Translating nanoscale physics to macro-scale predictive models requires physicists and engineers to collaborate on superlubric interfaces. This matrix summarizes the translation challenge across EUV lithography, quantum computing, and nanotribology, highlighting the gap between pristine physics and messy reality and the systems solutions required. Rethinking the architect means shifting from the isolated academic to the boundary spanner. The pivot happens when intellectual rigor is directed outward, integrating systems thinking and pragmatic iteration. The triple helix engine of academia, industry, and capital and state is vital. Abstract physics yields utility only when compressed by this three-part engine, forcing pragmatic iteration and ensuring patient support. Technological supremacy is achieved through profound, friction-heavy, interdisciplinary synthesis. The modern mandate is to embed the predictive elegance of fundamental physics into the chaotic reality of human existence.